There's something growing right now through the cracks of your sidewalk, something you have probably stepped over without a second thought. You may have pulled it out of your garden, sprayed it with herbicide, or watched it cling to your socks as an annoyance. But this plant, dismissed as a weed, has demonstrated the ability to fight drug-resistant bacteria more effectively than some prescription antibiotics. Not in theory, not in folklore, in controlled laboratory studies. It has been healing infections for thousands of years across continents, cultures, and civilizations. And in 2018, modern scientists confirmed what traditional healers had always known. Extract from its leaves outperform chlorhexidine, the gold standard disinfectant used in hospitals worldwide. The pharmaceutical industry has spent decades ensuring this plant remains classified as nothing more than a weed. In 1950, Alexander Fleming stood before the Nobel Prize Committee with a warning that would echo across the next century. Fleming, the man who discovered penicillin, told the world that bacteria would eventually learn to outsmart antibiotics. He cautioned that misuse and over-reliance would breed resistance. At the time, his words felt distant, almost hypothetical. Antibiotics were miracle drugs. They saved lives that had once been lost without question. But Fleming was right. By 2024, more than 1 million people were dying each year from infections that antibiotics could no longer cure. Deaths caused by methicillin-resistant Staphylococcus aureus, MRSA, have more than doubled since 1990, rising from 57,000 to over 130,000 annually. The Lancet projects that by 2050, antibiotic-resistant infections will kill 39 million people worldwide. In some regions, that is more than cancer and heart disease combined. And while modern medicine scrambles for solutions, one of the most powerful answers has been growing quietly alongside us the entire time. It is called Biden's pilosa. This is the plant that traditional healers never abandoned, and that Western medicine refuses to prescribe. When Spanish colonizers arrived in the Americas in the 16th century, they documented something they did not fully understand but could not ignore. Indigenous peoples across Mexico, Central America, and South America were treating infections with a plant they had cultivated and relied upon for generations. They used it on wounds that refused to heal. They brewed it for stomach infections, dysentery, fevers, and inflammatory conditions. To the colonizers, it went by many names: Achilla, Mozote, Amoro. To the indigenous communities, it had names passed down through centuries, each tied to lived experience rather than written text. What mattered was not the name, but the result. Infections resolved, wounds closed, fevers broke. Across the Pacific, Chinese healers had been using the same plant since at least the 7th century. In traditional Chinese medicine, it was known as Xianfeng Chao. Ancient medical texts describe it as an herb that clears heat and removes toxins. It was prescribed for enteritis, bacterial dysentery, pharyngitis, and infected wounds. This was not fringe medicine. It was integrated into a system that observed patterns over centuries, refining treatments through use, not patents. In Japan, the plant became the primary ingredient in kompot tea, a traditional remedy still used today for inflammatory skin conditions. In Africa, Biden's pilosa appeared independently in traditional medical systems across the continent. In Uganda, the Bafamara people applied fresh leaves directly to open wounds, calling it Inyabalazanya. In South Africa, healers used it for headaches, kidney problems, malaria, and even as an antidote to poison. During the Vietnam War, soldiers adopted the plant as both food and medicine, leading to its local name, the soldier vegetable. In Kenya, it was known as mika, eaten as a nutritious green, and valued equally for sustenance and healing. For continents, dozens of cultures, no shared language, no shared doctrine, no global communication, and yet all of them independently discovered the same truth. This plant fought infection. If you're finding the story eye-opening so far, take a moment to subscribe. Stories like this, where forgotten knowledge collides with modern science, are exactly what this channel exists to uncover. The question is unavoidable. What did they know that we have forgotten? In 2014, researchers in Brazil decided to test Biden's pilosa against one of modern medicine's greatest threats, oxacillin-resistant Staphylococcus aureus. These are superbugs that spread through hospitals, resistant to multiple antibiotics. killing patients who survived surgery only to succumb to infection weeks later. The researchers prepared extract from the plant's roots, stems, flowers, and leaves. They tested them against 60 different strains of resistant bacteria. The results were not subtle. They were extraordinary. Extract from the leaves inhibited the growth of every single strain tested. Every one. The mean inhibition zone produced by Biden's pilosa leaf extracts was significantly higher than chlorhexidine at 0.12%, the antiseptic used in hospitals around the world. This was not a mild antibacterial effect. This was a plant extract outperforming a pharmaceutical-grade disinfectant against bacteria responsible for over 100,000 deaths each year. And it did not stop there. In 2018, researchers tested Biden's pilosa against waterborne bacteria responsible for diarrheal disease, one of the leading causes of death in developing countries. Every bacterial species tested showed sensitivity to the plant's extracts. Antibacterial activity ranged from strong to exceptional, with minimum inhibitory concentrations between 0.6 and 10 milligrams per milliliter, levels that actually matter in real-world applications, not just petri dishes. A 2021 study examined Biden's pilosa against bacteria responsible for sexually transmitted infections. A dichloromethane extract showed significant activity against Neisseria gonorrhoeae, the bacterium that causes gonorrhea, as well as Gardnerella vaginalis. Multiple extracts were also effective against Candida albicans, the fungus responsible for persistent yeast infections. Another study focused on aquatic bacteria that devastate fish farms, Aeromonas hydrophila, Aeromonas dechensis, Edwardsia lectelluri, and Streptococcus agalacti. Biden's pilosa inhibited them all. This plant has demonstrated antibacterial activity against Pseudomonas aeruginosa, Staphylococcus aureus, Bacillus subtilis, Enterococcus faecalis, and Klebsiella pneumoniae. These are not obscure pathogens. These are the bacteria responsible for urinary tract infections, wound infections, pneumonia, and meningitis. These are the infections that send people to emergency rooms, and increasingly, the infections antibiotics fail to cure. If this knowledge matters to you, if you believe these conversations should be louder and more visible, subscribing helps keep them alive. The algorithm doesn't reward truth. It rewards attention. So why does this plant work? Scientists have identified more than 201 bioactive compounds in Biden's pilosa. These include over 70 aliphatic compounds, 60 flavonoids, 25 terpenoids, 19 phenylpropanoids, 13 aromatic compounds, and 8 polyacetylenes. Unlike single-target antibiotics, these compounds attack bacteria on multiple fronts simultaneously. Flavonoids and phenolic compounds disrupt bacterial cell membranes, causing them to leak and collapse. They inhibit cyclooxygenase pathways involved in inflammation. They interfere with quorum sensing, the communication system bacteria use to coordinate infections and form protective biofilms. They bind to bacterial DNA, preventing replication. They inhibit enzymes required for energy production and protein synthesis. And then there are the polyacetylenes. These compounds strongly absorb ultraviolet light and become activated by sun exposure. When applied to infected wounds and exposed to sunlight, they become more potent, killing bacteria, yeast, and even insect larvae. This is why traditional healers across continents independently discovered that fresh Biden's pilosa leaves applied to wounds and left exposed to air-healed infections faster than almost any other method. Modern studies have confirmed this traditional knowledge. A 2017 study showed that Biden's pilosa extract demonstrated antibacterial activity against E. coli, producing an 18.22 millimeter inhibition zone at 10 milligrams per milliliter, comparable to standard ampicillin at 30 micrograms per milliliter. The plant was competitive with pharmaceutical antibiotics. The evidence is no longer anecdotal. It is empirical. Traditional medicine was right. So why, in the face of mounting antibiotic failure, is Biden's pilosa not prescribed alongside, or instead of, failing drugs? The answer begins with patents. And that is where the story truly turns. You cannot patent a plant that has been growing wild for thousands of years. You cannot patent knowledge that belongs to indigenous peoples across 4 continents. You cannot claim exclusive ownership over a species that appears uninvited in gardens, fields, roadsides, and sidewalks. And you cannot easily isolate a single synthetic compound that outperforms the whole plant when the plant itself contains more than 201 bioactive molecules working together in synergy. This is where Biden's pilosa collides with a modern pharmaceutical system. Pharmaceutical companies invest hundreds of millions, often billions, of dollars developing new antibiotics. Between 1960 and 1980, the industry experienced what is now referred to as a golden age of antimicrobial discovery. Dozens of new antibiotics entered the market. Infections that once killed without mercy became manageable, even routine. But after 1980, development slowed dramatically. Companies began shifting focus away from antibiotics and toward more profitable drug categories. Chronic disease medications, taken daily for years or for life, generate consistent, long-term revenue. Antibiotics, by contrast, are taken for 7 to 14 days. Worse still, public health guidelines actively encourage limiting their use to slow resistance. From a business perspective, antibiotics became a losing investment. Industry analysts have been blunt about this reality. Pharmaceutical companies are reluctant to invest in botanical medicines because proprietary claims remain unclear. Richard Van Den Broek, an industry analyst, stated that most novel antibiotic research is now conducted by small biotechnology companies, not major pharmaceutical firms. The financial incentive simply does not exist. Between 1999 and 2014, fewer than half of new antibiotics that entered the global market were made available in more than 10 countries, and those countries were overwhelmingly wealthy nations. Access, not just innovation, became a defining crisis. The World Health Organization's latest review identified only 27 antibiotics in clinical development that target priority bacterial pathogens. Of those, just 6 were classified as innovative. The clinical pipeline is nearly dry. At the same time, a plant with proven broad-spectrum antibacterial activity grows wild in nearly every temperate and tropical region on Earth. But patents are not the only barrier. Clinical trials for botanical medicines are expensive and complex. Biden's pilosa contains multiple active compounds whose concentrations vary depending on soil conditions, climate, harvest timing, and extraction method. Standardization is difficult. What works consistently in a laboratory does not always scale cleanly to commercial production. Pharmaceutical-grade extracts require controlled cultivation, standardized processing protocols, rigorous testing, and regulatory approval. All of this costs money, and unlike synthetic drugs, there is no guarantee of exclusive rights at the end of the process. Meanwhile, synthetic antibiotics, even as their effectiveness declines, maintain market dominance through established regulatory pathways and intellectual property protections. The system is not neutral. It is designed for synthetic molecules, not whole plants. The cost of this design choice is not theoretical. The consequences are devastating. The Global Antibiotic Resistance Surveillance Report from 2025 analyzed more than 23 million bacteriologically confirmed cases of bloodstream infections, urinary tract infections, gastrointestinal infections, and gonorrhea across 110 countries. Resistance levels are rising across nearly every category. Deaths from carbapenem-resistant bacteria increased from 127,000 in 1990 to 216,000 in 2021. Third-generation cephalosporin-resistant enterobacterals now appear on the World Health Organization's critical priority pathogen list. These are bacteria resistant to last-line antibiotics, the drugs used when nothing else works. Even more alarming, 80% of the world's countries have extremely limited access to effective first-line antibiotics. Newer antibiotics that target resistant strains are even scarcer. In many regions, people are dying not because bacteria are resistant, but because effective treatments are simply unavailable. This lack of access accelerates resistance. Incomplete treatment courses, substandard drugs, and inconsistent availability create the perfect environment for bacteria to adapt and spread. If current trends continue, antibiotic-resistant infections will cause an estimated 169 million deaths between 2025 and 2050. The Lancet estimates that improving access to antibiotics, including alternative treatments, could prevent more than 50 million of those deaths. Biden's pilosa represents exactly the kind of accessible, affordable, broad-spectrum antimicrobial that could change the trajectory, especially in low- and middle-income countries where the plant already grows abundantly. If this perspective challenges what you've been taught about medicine and innovation, consider subscribing. These are not fringe ideas. They are evidence-backed realities hiding in plain sight. Half the world never stopped using Biden's pilosa. In China, it remains a mainstream herb in traditional medicine, collected and used by everyday people to treat common ailments. In Mexico, the young leaves and flowers are used for stomach disorders, hemorrhoids, and diabetes. In Africa, it continues to serve as both food and medicine, valued for treating infections, inflammation, wounds, and dozens of other conditions. In India, Biden's pilosa is used to treat glandular sclerosis, wounds, colds, flu, hepatitis, and urinary tract infections. This is not nostalgia or superstition. It is continuity, knowledge passed down because it works. Western medicine, however, largely abandoned plant-derived antimicrobials after the arrival of penicillin in the 1950s. Of the 25 to 50% of modern pharmaceuticals derived from plants, very few are intended for use as antimicrobials. Instead, medicine turned to bacterial and fungal sources, assuming they would always yield new solutions. That assumption is now collapsing. The plant that can help address the antibiotic resistance crisis is officially classified as one of the world's most common weeds. Agricultural Extension offices publish eradication guides. Herbicide companies sell products specifically formulated to kill it in lawns, gardens, and agricultural fields. Homeowners associations prohibit it. The entire infrastructure of modern horticulture treats Biden's pilosa as an invasive enemy, not because it destroys ecosystems, but because it grows everywhere without permission. Biden's pilosa is an annual herb that grows between 30 and 100 centimeters tall. It has bright green leaves with serrated edges and small yellow flowers surrounded by white ray florets. Its seeds are black, thin, and equipped with barbed bristles that attach easily to clothing and animal fur, one of nature's most effective seed dispersal mechanisms. This is why it is spread across the globe. Why it appears in driveways, gardens, vacant lots, agricultural fields, and urban waste areas. It thrives in disturbed soil. It tolerates a wide range of environmental conditions. It produces hundreds of seeds per plant. It is extraordinarily difficult to eliminate once established. And those same characteristics, resilience, accessibility, abundance, are precisely what make it such a powerful potential medicine. It grows where people live. It requires no special cultivation. It costs nothing. If you value knowledge that empowers individuals rather than systems, subscribing helps ensure this information continues to reach the people who need it most. Learning to identify Biden's pilosa is straightforward. The leaves are pinnately compound with serrated leaflets. The flowers are yellow with white outer petals. The black seeds cling stubbornly to fabric and fur. Traditional harvesting focuses on young leaves and flowering tops, collected from plants growing in clean soil away from roads and chemical treatments. The leaves can be eaten raw in small amounts, though they have a slightly resinous taste. They can be cooked like spinach, added to soups and stews, or dried for tea. Traditional preparation often involves making a decoction, boiling 1 to 2 teaspoons of dried aerial parts in water for 10 to 15 minutes, then straining and drinking up to twice daily. This is not medical advice. It is acknowledgement. Acknowledgement that indigenous peoples, traditional healers, and half the world's population have used this plant safely and effectively for thousands of years, while Western medicine spent 7 decades pretending it did not exist. And the reason it was ignored has very little to do with science. It has everything to do with profit, which leads to a more uncomfortable truth, one the medical establishment rarely confronts. Because Biden's pilosa does not just challenge antibiotic resistance. It challenges the entire economic model of modern medicine. And that is where the final consequences come into focus. The pharmaceutical industry does not want you to know that a plant growing in your driveway demonstrates antibacterial activity against MRSA comparable to hospital-grade disinfectants. The regulatory system does not want you to know that standardizing and approving plant medicines threatens the profit model of synthetic drug development. And the medical establishment does not want you to know that traditional knowledge, dismissed as folklore for generations, is now being validated by peer-reviewed scientific studies that confirm exactly what indigenous healers said all along. This plant fights infection. Between 1990 and 2021, more than 1 million people died every year from antibiotic-resistant infections. That number is projected to increase by nearly 70% by 2050. We are losing the war against bacteria. Not because we lack intelligence or technology, but because we abandoned the allies that fought alongside us for more than 4,000 years. Biden's pilosa has been treating infections across every inhabited continent for millennia, and yet in the modern world, it is classified as waste. Agricultural Extension offices publish manuals on how to eradicate it. Chemical companies engineer herbicides designed specifically to kill it. Municipal codes label it undesirable. Homeowners associations fine residents for allowing it to grow. The language is telling. Enemy, invasive, nuisance, not because it poisons soil, not because it collapses ecosystems, but because it grows freely without permission, without ownership, without profit. The irony is difficult to ignore. The very traits that make Biden's pilosa a weed are the same traits that make it one of the most accessible medicines on Earth. It does not require laboratories, factories, or global supply chains. It does not require refrigeration or sterile packaging. It grows where people live, especially where healthcare access is weakest, in regions where hospitals are understaffed, where antibiotics are scarce or counterfeit, where infections routinely become fatal. Biden's pilosa already exists as a living pharmacy, and in many places, people never stopped using it. In China, it remains a mainstream herb, sold in markets and gathered in the countryside. In Mexico, it is still used for gastrointestinal disorders and inflammatory conditions. In Africa, it continues to serve as both food and medicine. In India, it remains part of traditional treatment for wounds, infections, and systemic illness. Western medicine, by contrast, chose a narrower path. When penicillin arrived in the 1950s, it reshaped everything. Plant-based antimicrobials were sidelined in favor of isolated compounds that could be mass-produced, standardized, patented, and sold. For decades, the strategy worked. New antibiotics arrived faster than resistance could keep up, but bacteria adapt. They always have. The assumption that bacterial and fungal sources would indefinitely supply new antimicrobials is now collapsing under its own weight. The pipeline is drying up. Resistance is accelerating. Access is shrinking, and the cost is measured in human lives. The Lancet estimates that if current trends continue, antibiotic-resistant infections will cause 169 million deaths between 2025 and 2050. Improving access to effective antibiotics, including alternative and complementary treatments, could prevent more than 50 million of those deaths. Biden's pilosa represents exactly the kind of intervention that fits this need. Broad spectrum, affordable, locally available, and scientifically validated. If you believe this knowledge should not remain buried, take a moment to subscribe. Every subscription helps push evidence-based conversations like this into spaces that usually ignore them. Understanding this plant begins with recognizing it. Biden's pilosa is an annual herb, typically growing 30 to 100 centimeters tall. Its leaves are bright green, pinnately compound, with sharply serrated edges. Its flowers are small but distinctive, yellow center surrounded by white ray florets. Its seeds are black, thin, and tipped with hooked bristles that cling stubbornly to fabric and fur, ensuring the plant travels wherever humans and animals go. It thrives in disturbed soil, roadsides, gardens, fields, vacant lots. It tolerates drought, poor soil, and inconsistent care. One plant can produce hundreds of seeds, making it nearly impossible to eliminate once established. Nature designed it for survival. Traditional use focuses on the aerial parts, young leaves and flowering tops, harvested from clean environments away from roads and chemical exposure. The leaves can be eaten raw in small amounts, though their taste is slightly resinous. More commonly, they are cooked like spinach, added to soups, stews, or dried for tea. Traditional preparations often involve decoctions, boiling 1 to 2 teaspoons of dried plant material in water for 10 to 15 minutes, then straining and consuming up to twice daily. This is not medical advice. It is historical and scientific acknowledgement. Acknowledgement that long before clinical trials and regulatory agencies, people observed patterns. They noticed what healed and what harmed. They passed that knowledge down not through journals, but through survival. Modern science is now catching up. Studies have confirmed Biden's pilosa's activity against E. coli, Staphylococcus aureus, Pseudomonas aeruginosa, Klebsiella pneumoniae, Neisseria gonorrhoeae, Candida albicans, and dozens of other pathogens. Extracts have demonstrated effectiveness comparable to standard antibiotics and hospital disinfectants. Food preservation studies have shown it outperforming synthetic preservatives like BHT. Its polyacetylenes activate under sunlight, enhancing antimicrobial activity, exactly as traditional healers described. This is not coincidence. It is convergence. If this information challenges what you were taught about medicine, progress, and innovation, subscribing ensures you don't miss what comes next. These stories matter more than ever. The resistance crisis is not just a medical failure. It is a systems failure. A system that rewards exclusivity over accessibility. A system that values patents more than people. A system that dismisses centuries of empirical knowledge because it cannot be owned. Biden's pilosa exposes that failure simply by existing. It does not ask permission. It does not wait for approval. It grows anyway. And perhaps that is the most uncomfortable truth of all, because the solution to one of the greatest medical crises of our time may not require a breakthrough molecule, a billion-dollar investment, or proprietary formula. It may already be under our feet. We are losing the war against bacteria because we forgot how to listen to nature, to history, to the people who survived long before modern medicine told them what was possible. This plant has a name. It is Biden's pilosa. It has been fighting infection across every inhabited continent for thousands of years. And it is still here. If you believe stories like this deserve to be told, shared, questioned, and remembered, support the work by subscribing, sharing, and staying curious. The future of medicine may depend on it.